Hello, this is part 2 of the video trigonometry functions. We are going to be solving for the missing angle. Okay? So this is the problem on the right. The first step is to identify the angle of reference. Notice that this Greek letter called beta is on the outside with an arrow pointing to the inside. Sometimes this happens whenever there's not enough space to put that inside the triangle. But the angle of reference would be this angle that I'm highlighting in orange. Once you identify the angle of reference, the next step is to classify the three sides. Across from the angle of reference, we have the opposite. In this case, it's 12. Here is the 90-degree angle. Across from the 90-degree angle, we have the hypotenuse. And the third side is known as the adjacent. In this problem, we have a value for the opposite and the adjacent, which means we are going to have to use tangent because tangent is opposite over adjacent. Tangent of the angle of reference, which in this case is beta, equals our trig ratio would be opposite, which is 12, over adjacent, which is 20. We are solving for the angle, so we are going to have to use the inverse function of tangent. So this is the regular function tangent. The inverse would be tangent inverse, or sometimes it is written as arc tangent. The calculator that I use uses arc tangent. I will erase this because I need the space to show you the work. So when applying the inverse to the regular tangent, they cancel out, and that leaves you with angle beta equals, now I need to apply the inverse tangent to the left-hand side, and that's going to be apply this 12 over 20 inside the inverse tangent. So we're going to evaluate inverse tangent with 12 over 20 in order to get beta, and we will be using a calculator for this. Inverse tangent, again, this is the inverse, 12 over 20 equals, this tells us that our angle is 30.96 degrees. Since we are rounding to the nearest tenth, this becomes 31 degrees. Therefore, beta is equal to 31 degrees.